morning friends, welcome back to your favorite channel Code One Digest. Today in this video we will see how can we run our microservice and MongoDB both into container.
Yes friends, both of this application will be running in their separate Docker containers and we'll be connecting our microservice application to a MongoDB application and will perform certain get and post operations. We will learn step by step from downloading that image and running that image into a Docker container. We will do networking. We will learn networking. How can the connection be established between these two containers? What is bridge network? How can we do a port forwarding? How can we expose the port for external world? So there are a lot to learn in this video. I'm very excited about it. I'm sure it is going to be very exciting for all of us. So stay tuned till end of the video and I'll teach you step by step from scratch.
Okay friends, so here is the agenda for today. We will be pulling MongoDB image from Docker Hub repository. Then we'll start our MongoDB image into a container. Then we will build our microservice application image. Then we'll run our microservice application in a container. We'll connect our microservice application to the MongoDB running in a container, and then we'll test our microservices with some get and push commands. With me?
Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you.
Now let's understand the architecture of our flow today, what we are trying to achieve. So the outside box, what you see is a host machine. In that host machine, we are going to run one MongoDB container. This is our Docker container. And in that container, we'll be running our MongoDB application image. Okay. So MongoDB application image runs by default 27017 port. Okay. So this database is running on 27017 port inside this container. We have done the port mapping between the container port and the host port 28017 to connect it to our Mongo Compass application. So Mongo Compass application is running on host machine, hence it will access the application on 28017 port and it will pass the request to container 27017 port. So this is the setup for our Mongo Compass. But we have our API also running in another container. This is another container. So in Docker, there is a concept of network. By default, when you run multiple containers on a same machine, on a same host, Docker provides them a bridge network. So so one container is this where our MongoDB is running, and we have another container where our API is running, and both of these containers are connected through a bridge network. By default, Docker provide that. Do you see this white rectangle, dotted rectangle? It is a bridge network. It is showcasing a bridge network between these two containers. So inside a Docker, each container will get a unique IP address. Like I have given one sample IP address. Our MongoDB container has 172.17.0.2 IP address, and our springboot container has 172.17.0.3 IP address. So every container that you create or you start on a same host will be connected through a bridge network and will have a unique IP address. So when we are running our microservice application in a container, it has to connect to database via this bridge network. And to do that, our microservice application will be using the container port, not the host port, because it is a connection, it is a communication between the container to container. Hence, we will be using 27017 for our microservice application database configuration. And we will do another port mapping 8081 to 8081 to the host port so that we can access this API in our browser application or in our Postman application. So we'll be sending the request from browser or Postman on 8081 port of host machine, and that will go to 8081 port of our container port, and that is how we'll be accessing the APIs. Okay, clear? So what all communications we have here? We have done the port mapping. Port mapping is required when we want to access that application outside the container in the host machine. That is why we have done this port mapping 280.172 to 270.1.7, because we want to connect this database with our Mongo Compass application, which is running in host machine. Same way, our microservice application is running in a container on 8081 port, and we have done the port mapping with the host machine 8081 so that we can access it in a Postman or browser to call those APIs, right? And for internal communication, where our API has to connect to database, that time it will be using the IP address of that container, database container, and port of that container. Now we'll go and deploy our MongoDB application first. Now let's see some Docker commands. We are going to use this 4 or 5 Docker commands in this demo, and these are very simple to understand. I'll explain you each and every command one by one. So let's take the first command to pull MongoDB image from Docker Hub repository to our local repository. Let's do that. I have opened a terminal now. Just write docker pull Mongo 6.0.3. So this command will pull MongoDB image 6.0.3 from Docker repository to local repository. Okay, it is done. Docker images. We can see, okay, I have Mongo with 6.0.3. It is pulled now. I have another image, latest, but in this demo I am going to use 6.0.3. Okay, with me. Now our next command is docker run -d -p 280.1.7 Mongo. Docker run command is to start our MongoDB application, and here we are using -d option to run this in a detach mode. Detach mode means this MongoDB container will run in a backend, and we are doing a port mapping so that we will be accessing that database in a host machine on 280.1.7 as I shown you in an architecture diagram, and the container will run the MongoDB on 270.1.7 port. This is a default port of MongoDB. So we are doing the port mapping of default port to our host port 280.1.7 so that we can connect our MongoDB Compass and other application to see that. Let's run that. Let's see if any container already running. So nothing is running. Docker run -d -p 280.1.7 colon 270.1.7 and then image name Mongo 6.0.3. right? Let's do that. Yeah, now it says it's running. Let's see. Yeah, so our container is started. It is saying it is running, it is started. What we'll do is now we will connect our MongoDB Compass to this database and see if it is accessible. You remember I shown you in a diagram that we'll be connecting our MongoDB Compass on 280.1.7 to access our MongoDB application running in a container. Let's do that. Come to MongoDB Compass application, click on the connect option in the top. You will see a new connection. Click on the new connection link, and then you will be shown this window where you can provide your MongoDB URI. So here we are giving MongoDB localhost and port of the database, and this is a host port. So as we are running this MongoDB Compass application on a host machine, so we have to use our host port, that is 280.1.7. If you remember, we have done the port mapping for MongoDB and our host port is 280.1.7. Let's try connecting it and see if it is connecting. Yeah, so it is connected, and if you see, these are some default databases we have. Okay, we'll create our custom database in some time. So this is just to make sure that our database is connected and it is accessible. Friends, now let me show you my microservice application. It's a very simple application what I have written. So very first thing what you have to do is in the pom.xml you have to add MongoDB dependencies so that you can work with MongoDB libraries and connect to Mongo Database. It will give you, your application will have a driver and all of that, right? Then I have a customer controller where I have defined two endpoints, get endpoint and post endpoint. Get endpoint to get the customer information by name, and post endpoint to save a customer into database. This get and post methods are calling my business layer class. Okay, this is my business layer class, customer service. In this class I have these two methods, get customer by name and add customer to save customer. In these methods I'm using an instance of my customer repository. This repository instance is giving me the methods to find customer by name or to insert customer to save the customer into database. Let's see this repository class. This repository class is extending my MongoDB repository, and this is the repository class coming from pom.xml, that dependency we have added for MongoDB. So this class is coming from the dependency of MongoDB we have added in pom.xml, right? So you extend this Mongo repository, and our domain object is customer. It is having just few attributes like name, role, age and ID, nothing complex. And we have defined few operations here like find by name, passing name, and find by role by passing role. Find by ID and insert operations are already provided by default by MongoDB repository, so we need not to define it here, right? Very simple application. Now what we do is we have to define our configuration file application.properties where we have to give our MongoDB connection string. So here I have defined a string.data.mongodb.host and I'm reading it from environment variable. You have to do that because we are going to create image of this code base, and we'll deploy that image into a container. At the time of starting the container, in the run command of our container, we will pass this MongoDB host name, MongoDB port and MongoDB name in our run command. Why we cannot give that information now? Because we don't know the container IP address. What is the container IP address of my MongoDB? And even if I know that, tomorrow if the container restarts, or if we start another container, if we stop that container and start another container, then IP address will change. So to handle that problem, we have to read this information from environment variable. We should not hard code it here in the configuration file. It has to read from our run command. So I have defined the host, port and database here, but these values will come from our Docker run command when we start this application. So now what we'll do is we'll build a jar, and then we'll build our Docker image from it. Let's do that. Now what we'll do is we'll create a fresh jar for this project. So come into the Maven screen on your right hand side, select the target, that is clean and install, and click this button. So now it will create a fresh jar for us. Yes, so it's running some test cases. Yeah, so it says build is complete. That means our jar is created. Now what we'll do is we will create an image for this application. So let's see our Docker file, how our Docker file looks like. Okay, this is our Docker file. We have kept it at the root of this project. We are downloading the OpenJDK 8, and we are saying that copy all the jars available in target folder and put it in a container with the name application jar.jar and expose it 8081, because we are running our application on 8081. If you see, we are running our application on 8081, so we want to expose that 8081 for outside world. So we are saying expose 8081, we are opening that port. And what is our entry point for this? What is the command to start our application? Is java -jar application jar.jar. So this application jar.jar is the same name what we have given here while copying that jar into container, right? Very simple Dockerfile. Now let's go and run our build image command. Now what we'll do is we'll run this docker build command to build our application image. Let's understand what is this build command. Docker build -f Dockerfile. So here I'm saying that -f is for the file option. I'm saying that this is my Dockerfile. Please use this Dockerfile to build the image. And -c is for tagging. I'm tagging it with the name run microservice in container demo and dot, that means in current folder. Let's do that. We have to make sure that we are in the project directory. Let me clear this. Okay, I'm there in my microservice demo project. Here if I do ls, I can see my Docker file is there. Right now you do docker build -f, give a Docker file reference, and then -t for tagging. You can give name microservice in container demo. Okay, this is my tag name I'm giving, and say dot for current folder. Let's do that. So it is building. It will take few seconds to build your image. Yeah, so now it seems image is built. Let's see what all image we have now. Images, docker images is a command to see what all images we have. So this is what is built just now, right? 10 seconds ago. We'll use this image to start our application. Okay friends, now we have built the image for our microservice application. Now what we have to do is we need an IP address of our MongoDB container. So this is a command, docker inspect container ID. Docker inspect commands give you detailed information about a container, and it will also have a IP address information. It's a very detailed information. So we are using pipe grep command to only fetch IP address. Let me show you that. Let's go to another terminal. Let's do what all container we have. So this is our MongoDB container already running. Let's do docker inspect this container ID. It will give me very detailed information. It is too lengthy to read. So how can I get the IP address? I can run that command and do a grep IP address. It will search for this string in all of this JSON. Yeah, so here it is. It is giving me the IP address, and this IP address we will use in a command. So keep this IP address safe somewhere with you. 172.17.0.2. We will use this IP address for our application running command. Now we have the IP address of our database container. Before we proceed, let's create a database first. Okay, so here we don't have a database right now. What we have to do is we have to create a new database. Okay, so what I'll do is code one digest MongoDB demo, and collection name is like a table name. Here we are storing or dealing with the customer information, so I am giving a customer. Take this name. This name is also required. This database name will be required. Okay, so now the database is created. You can see the database is created, and in that database we have a customer, right? Let's try adding one customer here, one record in this database. We'll say name Pavan, then we'll say age 32, then say role value, right? We'll insert this. It's just a dummy data that we are inserting for our testing purpose. So one record is inserted, right? Now what we'll do is we'll prepare our application run command. So I have taken the IP address of my MongoDB container. I have know the database name and I know the port, and the port of the database is 27017. If you remember, this is container to container communication, hence we will use the container port. If you remember from architecture, so our application which is running in a container will connect to the container port 27017, not 28017. 28017 is for the host application which are running in a host machine. Okay, with me? So we are preparing this command. I'll prepare this command. If you remember, these are the environment variables we have defined in our properties file. MongoDB hostname, so I have given 172.17.0.2, then MongoDB port 27017, and MongoDB name. The name I have to give this name. Okay, yeah, I have given this name. Make sure there is no space or gap, and then -p for port mapping. I am doing a port mapping of 8081 host port to container port, and then my image. What is my image name? Let's take that from a container, Docker images. This is my image name. Let's take that name and replace. Yeah, this is my complete command to start my application. Let's do that now. We'll run our application container. If you see Docker PS, our MongoDB container is already running. Now we will run our application container. Okay, let me clear this. Let's paste this command. Okay, Docker run -e, and these are the environment variable that I'm passing. This environment variable we are using in our application configuration file, right? You saw in our application properties file we are using this MongoDB hostname, MongoDB port, and MongoDB database name. With me? Let me hit this. Starting the application. Yeah, okay, great. So it says it's connected. There is no problem. Mongo client, it's printing all the metadata, driver, everything is fine. Opened connection. Okay, it is able to connect to the database. Very good. That means we have established the connection between these two container. This container application, our microservice application, is able to connect to database application running on this port. Now what we'll do, friends, is we'll test this application quickly from our POSTMAN. Now we have started our application successfully on 8081 port. We'll go to POSTMAN and test our get endpoint. Okay, come to POSTMAN. I have prepared one get endpoint where we'll get the customer by name. So localhost 8081, as I said, we have done the port mapping between the host port to container port, and both the ports are 8081. Then customers Pawan, as we have inserted a record with the name Pawan in the database, we'll try to pull that with this name. Let's hit this. Yes, so I'm getting the data. Let's see the logs. Yeah, so it says found one customer by name Pawan. That means our container applications are able to work with each other. Our API is responding, it is able to connect to database, and so on. Now what we do is we'll try to insert one user, one customer into database. So I have created post contract where I'm using customer save and inserting a data name John and role employee and so on. Let's do that. Let's add this. Okay, so it says it is inserted successfully. We got 200 response. Let's go to Compass and see, do we have another user available? Just refresh this collection. Yes, so it says John is inserted here. Now we'll try to fetch this new user in our get contract. Instead of Pawan, I'll say John, John. Yeah, so it is returning me. We have a 200 response and we got the John customer, right? So we have done the get operation, then we have inserted one customer, and then we again pull that customer. So end to end, our architecture is working fine. Our application is working fine. Our application container is able to connect to MongoDB container, right? So this architecture is working fine. Remember where to use port mapping. Host port is only for the host application, and container to container communication happens on the container port. Always remember, containers by default are connected through a bridge network. If you want, you can create your custom network as well. Let me summarize what we learned in this video. So we pulled MongoDB image from a Docker Hub repository. Then we started our MongoDB image in a container. Then we build our microservice image. We were reading the database configuration from environment variable. We have defined like that. And then we started our microservice application in container by providing those environment variable value to those environment variables. And then we connected our springboot application with MongoDB. This is container to container communication, and then we tested our APIs with some get and post command. Okay friends,
If you like this video, so give it a thumbs up. And if you're new to the channel, please subscribe to the channel. Click on the bell icon for the latest video notification. I am creating a lot of quality contents, friends. So do share with all of your friends and colleagues. And do not forget to subscribe my channel to grow my Code One Digest family. Thank you.